In this demonstration, we're going to be discussing calculating power in a DC combination circuit. At this point in the circuit, we have all of our totals. We have calculated the total resistance at 22 ohms. We've calculated the total current flow at 0.54 amps, and we were given the source voltage of 12 volts. Now in the next circuit up, we walk this out. We have the 0.54 amps at both of those places because in this drawing it's a series circuit and current is the same at all points in a series circuit. We have a voltage drop of 5.4 volts on R1, and that leaves 6.6 volts left over for the parallel branch at R2. So we go up to the last circuit, the original circuit. We have the 12 volt source, R1's at 10 ohms, 5.4 volts dropped across it, and 0.54 amps. And going into the parallel branch of R2 and R3, we have 6.6 volts on both of those locations, R2 at 20 ohms, R3 at 30 ohms, and a current division on those two branches, 0.33 amps on the R2 branch and 0.22 amps on the R3 branch. So what we have left to do is to calculate power, and the power for the individual components is calculated the same way as it is in both the series and the parallel, and we can prove all of our numbers. So let's go ahead and take care of the power at R1 and use I times E, and that's going to be the current at R1 and the voltage drop at R1. So using the appropriate numbers, we have 0.54 amps times 5.4 volts will give us the power through R1 at 2.96 watts. Okay, calculate the power at R2. Use E squared divided by R, and in this case it is the appropriate E squared for the parallel branch, which is 6.6 volts, and the value of resistance for R2, which is 20 ohms. So 6.6 volts squared divided by 20 ohms of resistance for our power at R2 will be 2.178 watts. Okay, the power through R3. Use I squared times R. And in the parallel portion, we do have a division of current. Once again, making sure to use the correct current. So I squared in this case is 0.22 amps squared times the value of the resistor, which is 30 ohms. And that will give you a power through the R3 branch of 1.452 watts. And the last thing we have to calculate is total power. And as long as you're using your totals, you should be able to find everything, or you can add them all together because the same rules apply. We're going to use I total and E total to calculate the power total. So we have a total current flow in the circuit of 0.54 amps and the source voltage of 12 volts. Multiply those together, and that'll end up being a grand total of 6.48 watts of power in this circuit.